afternoon, Bearcats. We are now starting 1.9 inverse functions. I think you're going to find some of the things that we learned in 1.8 you will be using in 1.9. We're going to talk about inverses today, and these are the things that you should learn about inverses. You're going to find inverse functions informally and verify that two functions are inverses of each other. We're going to spend quite a bit of time on that today and in your classwork tomorrow. We're going to use graphs of functions to determine whether the functions have an inverse, using the horizontal line test to determine if the functions are one-to-one, which really means that they can be inverses of one another. And then we're going to find inverse functions algebraically. We'll do a little bit of that today as well. Our first example here is finding the inverse functions informally. I'm going to talk through the informal part, but I'm also going to incorporate some of the algebra in this very simple example. It says to find the inverse function of f of x equals 4x. Then we're going to verify that both f of inverse of x and the inverse of f of x are equal. That's a little confusing right now since you don't know exactly what that means, and we're going to do that in our next example. I want to just show you algebraically how we would find the inverse of this function. We would start with f of x, so I'm just using this as an example, equals 4x. And then what we would do to find this is the original function. What we would do next is we're going to change f of x to what we know it to be, which is y equals 4x. And then to take the inverse, or to algebraically find the inverse, and you did this a little bit in algebra 2, you're going to swap out your x and your y value. So we're going to say x is equal to 4 times y. And then you're going to solve for y. So our steps: change your function notation back to y, switch your x and y's, and then solve for y. And those are just the little short notes to finding a function algebraically. So if we solve for y here, we would take the 4 and divide by 4 on both sides. And if we did that, of course our 4 would be gone here, and you would end up with that y equals x over 4. That's almost the inverse. It's algebraically the inverse, but we want to write the notation back again to actually show the reader that you have an inverse here, and this is not an original function. Instead of writing just f of x, you write this little negative 1 at the top of x, and that stands for inverse. So the inverse of f of x is x over 4. And that would be, that was how the reader would know that this is an inverse versus this being the original. Because you could have started with this as the original and found this to be the inverse, found the first one to be the inverse. So you have to give the reader something to go on. All right, let's go to page 2. Anytime today, if you need to stop and pause this and take your notes, all of these are pretty good notes for this whole section since this is the introduction of it. You may want to stop and go ahead and take your notes down before you move on. I'll be right here waiting for you when you get back. All right, example 2, we're going to verify inverse functions. And I have to tell you that we're going to do this a lot in this unit. This is going to happen a lot. I'm going to try to move that up a little. Let's see if I can move this up. Maybe not. We're going to do this a lot. Problems, I think 13 through 21 are part of your classwork tomorrow, and I want you to work really hard to understand that. And this is the example, and the next one, they're going to really help you be able to do that well. All right. In this case, we're going to find out which of these functions is the inverse of this original function. For functions to be inverses, when you do a composition of those functions, and we did compositions in the last section, when we do that, then they both should come out to be x. So let me show you how that works. So we're going to first compare f of x with g of x. So I'm going to, where you have your f of x and you have your g of x, and we're going to go f of g, and we're going to see what happens. Remember, on our last unit, we wrote that as f of g of x. So what does that mean? That means we're going to take the information of g of x, which is this, and we're going to plug it in for this x to see if they come out to be just simply x, which would mean they're inverses of one another. Let's see what happens. So when I do that, I would have 5, and instead of x now, I have x minus 2 over 5, and then I still have minus 2. Now, this is a little tricky. This is the algebra. This is the inverse part. This is the algebra part from here on. So pay really careful attention. This is where you probably will have most of your trouble. Remember, a fraction bar is the same as old-fashioned division. So I'm going to rewrite this as 5 divided by x minus 2 over 5 minus 2 over 1. Okay, that algebra is where you're going to get caught a little bit. All right, the next thing I'm going to do is we're going to multiply by the reciprocal. But before I multiply by the reciprocal, I need to make sure I've combined everything here. I cannot add or subtract fractions without finding a common denominator. My common denominator would be 5. That would mean I would need to multiply this side by 5 and the top by 5 because we're fair and equal. We did this earlier this year. So you would end up with x minus 2 minus 10 at the top, which is really x minus 12 over 5. So now we have, I'm going to just, write it, x minus 12 over 5. And now we have 5 divided by, and we're going to multiply, so we have 5 times the reciprocal. I didn't do a very good job of that. Oops. Erase this here. All right. Since we know this is going to be 12, sorry, I'm going to just draw a line to that. That's going to be x minus 12 over 5. So just kind of cross that out and we can erase it. So now I'm going to multiply 5 times 5 over 1 times 5 over x minus 12. And we have what? 25 over x minus 12. All right, well, 25 over x minus 12 does not come out to be x, so this is not an inverse of the first one. All right, let's see if we do it with the second one, how we come out. So with the second one, we're going to try f of g of x. So we have f of g of x. Let's see how that comes out. All right, so we're going to take our, and actually h of x, not g this time, so sorry. So this g will become an h. So we're going to use this function, compare it with the f function. So f of h. So we're going to take the h of x information, which is all of this, and this time we're going to plug it in for this x. So let's try that. So now we have 5 over, and now we have 5 over x plus 2, and then we have minus 2. All right, well, 5 over x plus 2 minus 2, our 2's will cancel, and you have 5 over x, oops, 5 over 5 divided by x, which we know that big fraction bar is like division, so you have 5 divided by 5 over x. And now we're going to multiply by the reciprocal, so we're going to say 5 times x over 5. I put a 1 over this, my 5's will cancel, and this will equal x. I'm going to make a big happy face guy, because that, and maybe even a party guy, that equaled x. So this is the inverse of this. So these two functions, h and f of x, are inverses. Okay. All right, let's move on to the next example. Or pause this and write this down again. Oops. All right, our next example. We're going to determine whether the two functions are inverses of each other. And technically what you need to do is you need to fog and golf in this situation. I'm going to leave this second example for you. We'll do it together. We'll actually do it together. But we're going to first work on part A. All right, I'm going to switch back to my blue pen. And we're going to try fog and golf with this. So we have f of g and we're going to do G of F. And this is, again, what you're going to be doing a lot in your homework or your classwork tomorrow. So remember, this is F of G of X, and this one's going to be G of F of X. All right, and we'll see what happens. So for the first one, we're going to take the G function, which is all of this, and plug it in for the X and the F function. Let's see what happens. So if I go 3 parentheses, and for my X, I put 1/3 X plus 2, and then I still have minus 2. Let's see what happens here. Well, 3 times 1/3 would just be X, and 3 times positive 2 would be 6, minus 2, and we would have X plus 4. All right, not an inverse. So we can just stop right there because we don't even have to go the other way. We know they're not inverse of each other because the F of G of X didn't lead us to just the value of X in the end. So we can just stop on that one. I would say pause right now, write that down, make sure you understood that because this did not come out to be just X, that we don't have an inverse yet. So I'm not even bothering with the other one. And then we're going to do the second one, part B. Part B. I'm going to erase so I have more room to write. So you might want to push pause before I erase. All right, I'm going to erase. That's magic, isn't it? Fun. I do this pretty good. I don't play video games very well, but I do this pretty good. All right, here we go. So in the second one, we're going to fog and golf. So we're going to F of G of X, and then we're going to maybe do G of F of X if the first one works out, just to determine if they are inverses of one another. But sometimes it can work one way but not going the other. So we're going to take our G function, which is this information right here, and we're going to plug it in for this X and see what happens. So we're going to get 1/4, and then for the X, we're going to plug in 12 plus 4X. And we have minus 3. All right, well, 1/4 of 12 is 3. And 1/4 of 4X would be just X. And then we have minus 3. Oh, yippee. Looky here. Our 3's cancel and we just have X. Okay, that deserves a party guy. Yippee. All right, go Bearcats. Next, we're going to try, since it worked on this one, we're going to try to reverse. We're going to take F of X, which means we're going to take all of this information this time, and we're going to plug it in for this X. So we have 12 plus 4 times parentheses, and we're going to plug in 1/4 X minus 3. All right, so we have 12 plus 4 times 1/4 X is X. 4 times negative 3 is negative 12. Oh, whoopee. All right, so our 12's cancel, and we just have X. I believe then our party guy deserves a party girl. So we got a little party girl going on here, party hat. All right, so go Bearcats. So because they both came out to be just X, they are inverses of each other. Really important, you're going to work on classwork. All right, our last example for today. By the way, I missed you this week. Hope you had a good one, and I hope that you're safe. All right. Talking about graphs just a little bit. We're going to look at graphically what it looks like, and then we're going to talk about how you could determine it if you had one of the graphs already, how you would determine graphically an inverse. The graph of an inverse function, the graph of a function of f and its inverse, f of the little negative one at the top, the inverse, remember that notation is really important, are related to each other in the following way. So if AB, x and y basically, lie on the graph, then in the inverse, it'll be BA. The x and the y will be switched. We saw that when we saw algebraically. So, let's talk, so that's just kind of visually what an inverse would look like right here. Notice also that you have a reflection line of x equals, or y equals x. This dotted reflection line is y equals x. And the graph is reflected over that particular line. I really like this example right here. So notice for every point, I'm just taking this negative 1, 1. This is your x and your y. Then on the inverse, you have switched those. This is your x and this is your y. So x was negative 1, now y is negative 1. Y was positive 1, now x is positive 1. So if you had an original graph, you could take a set of ordered pairs, switch the ordered pairs, the x and y ordered pairs, graph the new points, and come up with your inverse graph. And we will be doing that, and I believe you'll have at least one on your test. Again, it did reflect over the dotted line, which is the line y equals x. Okay, that's it for tonight. You might write those examples, especially this one with the way you change out. You would kind of create a table of values. You would write your ordered pairs here, and then to write the inverse, you would switch them. So if this again was negative 1, 1, and you're going to write for the inverse 1, negative 1. There was another point on here, negative 5, negative 1. So your inverse would be negative 1, negative 5. There's several on here. Notice 3, 3, they cross, and that will happen with all of your inverse functions. There'll be a point that they occasionally share. And this first one, it was right here. All right, good night. Hope you have a great evening, and I will see you tomorrow. We look